What is a vector? Vector is a quantity having direction as well as magnitude, as determine the position of one point in space relative to another. It is denoted by an arrow with a specific length and direction. Vectors are used in various fields, including physics and engineering. They are essential for describing physical quantities such as velocity, force, and weight. Car traveling toward direction, weight as a force with direction towards the center of the earth, and friction is a force which tend to oppose an object's motion. In this video, we will be explaining the conversion of a rectangular to cylindrical coordinates and vice versa.
Hi guys, I'll be introducing the difference between a rectangular coordinates, which is shown here, and the cylindrical coordinates, which is the example here. So for rectangular coordinates, they are used to find the location of the point with respective to the origin, which is shown here. So it consists of three coordinates, which is x-axis shown here, y-axis, and z-axis for 3D purposes. It is widely used for location such as compass and 3D for longitudinal and latitudinal coordinates of the Earth. The only difference is that cylindrical coordinates, r will be replaced for x, y will be replaced for theta, and z will be constant for the height. Example of cylindrical coordinates are this bottle can be used as a volume.
So for this slide, we are going to talk about how to converting rectangular coordinates to cylindrical coordinates. First, in order to convert rectangular coordinate to cylindrical coordinate, we need to find the magnitude, which we use r squared equals to x squared plus y squared. Then we need to find the argument, which tangent inverse equals to y over x. So vice versa, we want to find the cylindrical to rectangular coordinates. We use x equals to r cosine theta to find the x coordinate, and y equals to r sine theta to find the y coordinate. So we assume that the height will never change.
Now let's try an example, using the equation to convert Cartesian coordinates to cylindrical coordinates. The Cartesian coordinates of the rectangles are 2, -6, and 10. So using the formula, we can first find r, where r is equals to square root of x squared plus y squared. In this case, we will use the positive value square root, which is square root 40. Now let's find theta. Because y is a negative value and x is a positive value, therefore theta lies on the fourth quadrant. So using the cast method to determine the location of the quadrant by starting from the bottom right C and moving anti-clockwise direction. As we know, tangent theta is equals to y over x, which is in this case -6 over 2, which gives us -3. So to find theta, we will take tangent inverse -3, which is equals to -1.25 radian. Our theta has to be between 0 and 2 pi, so therefore theta is equals to -1.25 plus 2 pi, which approximately gives us 5.03 radian. And the z coordinates in both Cartesian and cylindrical coordinates are the same, so z is equals to 10. Therefore, the point with the Cartesian coordinate 2, -6, 10 as the cylindrical coordinate approximately equals to square root 40, 5.03, and 10.
In conclusion, Cartesian coordinate system describes the location of point in space, while cylindrical coordinates are useful for dealing with problems involving cylinders, such as calculating the volume of a round water tank or the amount of oil flowing through pipe. In each of the following situations, we determine which coordinate system is most appropriate and describe how we oriented the coordinate axis.